All right. So today we are doing AS level chemistry paper 1 MCQs. The year is May June 2024. Paper 1 variant 1. Let's start with the first question. Sample X is added to water and made up to a total volume of 200 centimeter cube. This gives a solution of 0.100 mole per dm cube HCl. What is X? So what would X be? To do this kind of question, you see a simple pattern, all right? Whenever we talk about dilution, this question is about dilution. Whenever we talk about dilution, we use a very famous formula. It's called C1V1 is equals to C2V2, all right? They have told us that the final volume of solution V2, the final volume of solution V2 is 200 centimeter cube, and the final concentration of solution is C2 0.1 mole per dm cube. Now they're asking for a combination of V1 and C1 that could give us the same answer as the combination of V2 and C2. So all we have to do is by putting 200 0.10 multiply by 200, and over here we don't even have to change the unit because on both sides the unit of centimeter, the unit is in centimeter cube, so we can keep the unit over here. All right, we do not have to change. Even though the concentration is in mole per dm cube, over here we do not have to change. We can do it without changing the formula. All right, so any one of these options, when they are multiplied with each other, they should give us this much. All right, um 1 second. All right. So any of these should be equal to zero point 0.1 times 200. All right. So let's do the first one. What is 0.1 times 200? Let's find that out. 0.1 multiplied by 200 should give us 20. All right. So any one of these when multiplied with when multiplied together should give us 20. All right. So when 10 times 1, that is 10. This is not correct, right? This is wrong. We just have to multiply them. All right. 30 times 0.9, 30 times 0.9, that is equals to 27. It is still not 20, so this is also wrong. What is 50 times 0.4? Let's check that. 50 times 0.4, that is equals to 20. All right. So this is our answer because 0.5 times 50 times 0.4 is giving us 20. So therefore our answer is C. All right. Next question. A mixture of 10 centimeter cube of methane and 10 centimeter cube of ethane was sparked with an excess of oxygen. After cooling, the residual gas was passed through aqueous potassium hydroxide. All gas volumes were measured at the same temperature. All right. So which volume of gas was absorbed by the alkali? Now, the very famous thing is you should remember potassium hydroxide absorbs carbon dioxide. AbSORBS absorbs carbon dioxide. All right. So it it absorbs carbon dioxide. All right. Um, though 10 centimeter cube of methane and 10 centimeter cube of ethane, when they were sparked with an excess of oxygen, they will produce how much amount of carbon dioxide that is basically going to be absorbed by potassium hydroxide. All right. So for that, we have to write the equations. All right. First, CH4, which is methane, it is reacting with excess of oxygen. It produces carbon dioxide and water, right? Okay. So we need to only balance carbon dioxide over here. We don't have to balance the whole equation. However, we can if we want. All right. It's not going to take so long, but you do not have to really. All right. For example, this one, CH4 and CO2 will remain 1. We will put a 2 over here. So we will have to put a 2 over here as well. Okay. The next equation is ethane, C2H6. All right. First we did the equation for methane. Now we're doing the equation for ethane. All right. C2H6, when this reacts with oxygen, it produces carbon dioxide as well and water because we are producing in excess of oxygen, right? To balance the equation, we'll have to put a 2 over here and we'll have to also put a 3 over here, right? H2O, and we'll have to put a how many oxygens are there now. 2 2s are 4 and 3 1s are 3, 7. So we'll put a 7 upon 2 over here. All right. Balancing oxygen and water was not necessary. I'm telling you once again, we are just doing it because we want to completely balance the equation. Now 10 centimeter cube of methane when it is burned will produce 10 centimeter cube of carbon dioxide, and 10 centimeter cube of methane when it is burned will produce 20 centimeter cube of carbon dioxide, because the mole ratio is 1:2 for this guy, and the mole ratio for methane and carbon dioxide is 1:1. All right. So in total 10 and 20, 10 plus 20 equals 30 centimeter cube of carbon dioxide is produced, right? So it must be absorbed by the potassium hydroxide. So what would be our answer? Our answer would be C, because 30 centimeter cube of carbon dioxide is being produced in this equation. Next question. Z is a compound of two elements X and Y. Element X shows a very large increase between its fifth and sixth ionization energies. It has the second largest first ionization energy in its group. Element Y shows a very large increase between its sixth and seventh ionization energy. It has the largest first ionization energy in its group. What is the compound Z? Okay, so Z, it is made from X and Y, and X and Y, they are both two hints we have been given. First is that it has the second largest ionization energy in its group. Now, when we talk about a group, ionization energy down a group, it decreases, right? Meaning the guy at the top, for example, let's talk group 1, lithium is at the top, right? And then we have at the bottom in group 1, we have, I think, francium, right? FR maybe. I don't exactly remember the symbol, but let's suppose के um let's suppose that lithium is the first one and francium is the last one. Lithium has the highest ionization energy, right? And francium has the lowest ionization energy, because ionization energy down the group decreases. Okay, so we can write that as a statement for you to remember that lithium, sorry, not lithium, ionization energy decreases down the group. All right, that is the first, that is the main thing. All right, now when we talk about element X, it shows a very large increase between its fifth and sixth ionization energy, meaning it has 5 outer shells. How many outer shells does it have? 5, meaning it is in group 5. All right, how do we know it is in group 5? Because first of all, it is in group, as we can see that it is in group, it is not a transition element, and then it has the largest increase of ionization energy between fifth and sixth. That means the shell is changing after the fifth electron. Right. Similarly, for element Y shows a very large increase between its sixth and seventh ionization energy. If it shows a large increase between sixth and seventh ionization energy, that means it must be from group 6. Right, it must be from group 6. Okay, and it has the largest first ionization energy, so it is the first element of group 6. And the first element of group 6 is oxygen, right? First element of group 6 is oxygen. And group 5 is the one in which we have nitrogen, phosphorus, and then gallium, I think, or whatever is beneath them. You don't really have to memorize the periodic table. You can go through the periodic table, it's at the end. But if you remember, so it is, we only need to know the second, because it says that this guy, element X, has the second largest ionization energy in its group. Second largest means second from the top, and second from the top means second element of group 5, and that is phosphorus. So our compound should be phosphorus, made from phosphorus and oxygen. Our compound should be made from phosphorus and oxygen, right? So what would be the answer? Answer would be CP4O10. That is the only compound which has phosphorus and oxygen. All right. Next question. Which statement about 13153I is correct? A negative ion of 13153 contains 53 neutrons and 52 electrons. Okay. If it has 53 protons, then it can't have a negative ion if it has 52 electrons because there is one more proton. So this statement is wrong. This is a positive ion. A negative ion of 13153 contains 53 neutrons and 54 electrons. Well, 54 electrons is correct, right? 54 electrons, that part is correct. But does it have 53 neutrons? To calculate how many neutrons it has, we'll simply just subtract the atomic number and atomic mass, right? The atomic mass is the one on top, 131, and atomic number is 53. When we subtract them together, we get 78, not 53, right? So this statement was wrong as well. Similarly, in the above one, this statement is also wrong. It should have 78 neutrons. So this is wrong now. Okay, so next, a negative ion of 13153 I contains 78 neutrons, that is correct. And 52 electrons, no, it can't contain 52 electrons. If it has 52 electrons, then it would be a positive ion because it has one more proton. Iodine has 53 protons, right? So it must be, the correct answer must be D. Let's look. A negative ion of 13153 I contains 78 neutrons and 54 electrons. That is the correct statement. Next question. When solid aluminum chloride is heated, Al2Cl6 is formed. Which bonding is present in Al2Cl6? All right. So in Al2Cl6, we know that it is a simple covalent compound, so it must contain covalent bonding. And then we also know that it contains dative bonding because two chlorines in the Al2Cl6 are donating both their electrons to aluminum, right? A diagram of it is also present in the notes. You can go visit that. Next question, the structure of sulfur dioxide molecule is shown. What is the shape of sulfur dioxide molecule? Now, the shape of sulfur dioxide molecule, how would we know? Look, because sulfur dioxide, as you can see, it contains two double bonds and a single lone pair, right? It doesn't contain two lone pairs. It contains a single lone pair and it is bonded to two atoms, right? So it can't be completely linear because of the presence of lone pair. If there was no lone pair, then we could say that it is linear, but this can't be linear, right? So it would have to be non-linear, meaning it has some angle between the it looks like it in nature it would actually look a little something like this, right? This would be what it would be looking like. This is a non-linear shape. Okay, pyramidal and tetrahedral are obviously wrong because tetrahedral central element needs to be connected to four guys. Pyramidal central element needs to be connected to three guys. Over here, central element is only connected to two atoms. Next question, what is the density of sample of fluorine gas at 32 degrees Celsius and 100,000 pascals? Assume fluorine behaves as an ideal gas under these conditions. That formula for density is mass upon volume. The formula for density is mass upon volume. The things they have given us lead us to believe that we should use the formula PV is equals to nRT. PV is equals to nRT. Okay. Now, one more thing. This is a complicated thing because we can't really find out what density is without doing a few derivations. Derivations means that you have to make some formulas yourself. So moles is equals to mass upon molar mass mr. So instead of n in this equation, we can write PV is equals to m upon mr multiplied by RT. Okay. We can even write it like this, MRT upon MR. Okay. Now MR can go on this side. MR can go on this side. All right. And this will become PV multiplied by MR is equals to mass multiplied by RT. All right. And then we can bring V on this side, make it divide, and RT goes on the other side and goes in division as well. So it becomes P multiplied by MR divided by R multiplied by T is equals to mass upon volume. Mass upon volume is equal to our density. So we can write density is equals to pressure multiplied by MR of fluorine divided by R multiplied by temperature. Now everything that you need is in front of you. Look, you have been given the temperature, you have been given the pressure, you have been told that the gas is F2, meaning its MR is obviously going to be twice the mass of fluorine atom. You go to the periodic table, look at the mass of fluorine, let's look at the mass of fluorine. The mass of fluorine is 19.0. All right. So we go back up. Where did it go? We go back up, right? And we will write the formula like that. Okay. So it's the mass of fluorine is 19, right? Okay. So we will write rho is equals to pressure, which is 100,000 multiply by mr. Mr is 19 times 2, that is 38. Okay. Divided by R. The value of R is 8.31. If you sometimes forget, then uh, if you forget, then um, what you need to do is just go and check it at the end. There is the value of R is also given in the question paper as well. And temperature is given in 32 degrees. You have to convert it into kelvins. So it will become 273 plus 32. So let me do 273 plus 32. This is equals to 305. This is equals to 305, right? So temperature would be 305. When we do all this, I'll have to erase this because we need another column. So density is going to be equal to, let me do it, 100,000, right? 1, 2, 3, 100,000 multiply by 38 upon 8.31, 8.31 and 305. So we are getting the answer 1499.28 gram per meter cube. All right. Why gram per meter cube? Gram per meter cube because in this general gas equation or ideal gas equation, volume is in meter cube. Volume is in meter cube, right? So the density we've gotten is in gram per meter cube. If we want to change meter cube into decimeter cube, if we want to change meter cube into decimeter cube, we always um, one second. If we want to change meter cube into decimeter cube, so basically this means that in in one meter cube there is 1499.28 grams of F2, right? 1000 meter cube basically means 1000 dm cube. 1000 meter cube basically means 1000 dm cube. So basically in 1000 dm cubes there is 1499.28 grams of fluorine. So how much would there be in just 1 dm cube? You can simply cross multiply, or basically how have I gone down? I've divided this by 1000, right? So I can go and divide this side by 1000 as well. All right. So density in dm cube would actually become in 1 dm cube. In 1 dm cube, we would have 1000. We'll divide this by 1000 and we'd get 1.499. Everything is to only one decimal place. So we'll do 1 dm cube equals to 1.5 gram per dm cube, right? Or just 1.5 gram. So we can say density in dm cube is going to be 1.5 gram per dm cube. So the answer would be B. All right. On to the next question then. Question number 8. The graph shows the boiling point of hydrogen compounds of group 16 elements. All right. H2O with the highest. Which statement correctly explains why water does not fit the trend of the other compounds? So why is water not following? Well, because we've discussed why does water have a high melting boiling point? Because bit of water has hydrogen bonding. All right. So let's look at anything that says hydrogen bonding or anything. So let's see. There are fewer electrons in the oxygen atom, so there is less shielding. Well, that doesn't tell about hydrogen. There are strong hydrogen bonds in water, but not in other compounds. Such a simple and straightforward answer. So this should be B, right? Water has strong hydrogen bonds. Next question. An energy cycle is shown, all right, X, Y, and Z. The energy changes involved are X, Y, and Z. The numerical value of Y is either minus 890 or plus 890. The numerical value of energy change Z is either minus 194 or plus 194. Which of the values are negative? So if they're saying that X, well, We know from looking at this, we can for 100% surety, we can be sure that this value should be negative. Why? Because this is a combustion reaction. This is a combustion reaction, right? So because it is combustion, so this value should be negative. Similarly, this value should also be negative. Why should this value also be negative? Because it is also a combustion reaction, carbon burning with oxygen, hydrogen burning with oxygen. All right. So both are combustion reactions. All right. So we'll say Y and Z are both combustion reactions. Hence, they are always exothermic. They are always exothermic. All right, so C should be the right answer. On to the next question then. For a certain endothermic reaction, the activation energy is numerically equal to twice the enthalpy change of reaction. Which reaction pathway diagram is correct for this reaction? All right. So for this question, beta, they have given us a statement that the activation energy is twice the enthalpy change. So whatever is delta H, energy of activation should be double that. Okay. So in the first one, and also moreover, we also have to consider that the reaction is endothermic, right? Meaning C and D are already wrong because they are also exothermic. Okay, so the answer is either A or B. Let's look at A. In A, the activation energy is this much, all right, which is 3 boxes, and enthalpy change is just 1 box, right? So energy of activation is thrice that of enthalpy change, which is only once, right? So this cannot be correct. So the correct answer should only be B, but let's confirm. So in this one, energy of activation, let's call it roughly 2, and enthalpy change, let's call it roughly 1, right? So energy of activation, which is EA, and this is delta H, is just 1. All right, so the answer is B. Next question. Question number 11. Sodium chromate 6 Na2CrO4 is manufactured by heating chromite FeCr2O4 with sodium carbonate in an oxidizing atmosphere. Chromite contains Cr2O4 2 minus ions. 2 FeCr2O4 plus 2 Na2CO3 plus 3.5 oxygen plus it gives 4 Na2CrO4. All right, plus Fe2O3 plus 4 CO2. What happens in this reaction? All right, so what would probably be happening in this reaction? The question is about oxidizing and reducing. So so we have to go about and see which one is the correct by finding their oxidation states. All right, so let's look in the beginning, in the first bit. um So chromite contains Cr2O4 2 minus, right? Which means Fe over here is plus 2. And Cr over here, what would be Cr? Because 4, so this is minus 8. So Cr is plus 3 over here. How do I know Cr is plus 3? How do I know Cr is plus 3? It is because let's just write whole values like minus 8 because oxide is minus 2. So this must be Fe is plus 2 we've established, and because each Fe is plus 2 over here, all right, and Cr is a total of plus 6 because each Cr must be plus 3. There are two Crs, right? Okay. And the next thing is sodium. Sodium is plus 1 over here. It is always plus 1, still a compound, so it is still plus 1 over here. All right. O3 is minus 6, so C must be plus 5. Sorry, so sodium, wait a second. C must be plus 4. C must be plus 4. Sodium in total must be plus 2 because one sodium is always plus 1. Carbon is plus 4 over here. Oxygen is minus 2 over here as well. All right, over here oxygen is 0 because it's a diatomic molecule. Each sodium over here will also be plus 1. So a total of plus 2 will be provided, right? And and the sodium, because each one of them is just +1. Okay, each sodium is just +1. All right. Next, if you look at the next thing, it is Cr and O4. So the total Cr must be the total O4 must be -8, because each oxide is -2, and there is one Cr over here which must be +6. So Cr over here is +6. Okay. Next, if you look at iron oxide, three oxides meaning -6. So two irons must be +6. So each iron must be +3 over here, because oxides are -2, right? Oxide is always fixed, right? And then we don't even have to see CO2, or we can even see CO2 if we want. C is +4 over here, right? Because oxides in total are -4, because each oxide is -2, and C is +4. Uh, each oxide is -4 like this. Okay, so carbon is +4. So in this equation, what do you see? Do you see someone getting oxidized? So you will see that Fe is indeed oxidized. All right, that is oxidation. And you can also see that Cr is also oxidized. All right, both are oxidized. +3 to +6, Fe +2 to +3, and then is this oxide is just -2, this oxide is -2, uh this oxide is 0, so this oxide is -2, -2, -2. So we can see that the oxygen itself got reduced. Who got reduced? Oxygen, right? This is reduction. This is reduction. All right, this purple is oxidation, red is also oxidation. All right, so let's look at the statements now. Chromium and iron are the only elements oxidized. That is true. So we've just found our answer. Chromium and iron, they are the only two that have been oxidized. Iron has gone from +2 to +3. Chromium has gone from +3 to +6. Okay. Next question. Oxygen can be prepared by the reaction of potassium magnate A7, KMnO4, hydrogen peroxide H2O2, and sulfuric acid H2SO4. Each H2O2 molecule loses 2 electrons in this reaction. The other products of the reaction are potassium sulfate, manganese 2 sulfate, and water. How many moles of oxygen gas are produced when 1 mole of KMnO4 reacts with an excess of H2O2 in acidic conditions? For a question like this, you will have to write down the equation. And the equation that you can see from this is that hydrogen peroxide is reacting with KMnO4 in presence of sulfuric acid, right? So let's write H2O2. One second. Let's write H2O2 plus KMnO4 plus H2SO4. All right. And it has told us the products, right? Oxygen is prepared, and along with that, other products are potassium sulfate, manganese 2 sulfate, and water. So we can say that water is prepared, right? We can say that oxygen is prepared. We can say that what else is prepared? Potassium sulfate, K2SO4, all right? And we can even say what else is prepared? Manganese 2 sulfate, MN I think SO4, MnSO4. Yeah, manganese 2 sulfate, Mn, because manganese has a +2 charge now. All right, so manganese 2 sulfate, MnSO4. Okay, now how many moles of oxygen gas are produced when 1 mole of KMnO4 reacts with an excess of H2O2 in acidic conditions? For that, we have to write the balanced equation. To balance this equation, beta, because this equation contains 3 reactants and 4 products, balancing it by trial and improvement is going to kill you. It's going to take all the time in the exam, all right? And you might still not get it correct. So what is another way of balancing? Another way of balancing is balancing by loss and gain of electrons, all right? Balancing by loss and gain of electrons, okay? Now some things that you can remember for life: when H2O2 reacts, it usually gets oxidized or reduced, one of the two, okay? Like for example, KMnO4 is an oxidizing agent. So in this case, H2O2 is going to get oxidized. And what is going to get oxidized in H2O2? The oxygen. All right. So you can clearly see O is -2 over here, right? And it has just gone to 0 over here. It has just gone to 0 over here, right? How would it have gone from -2 to 0? By losing 2 electrons, right? This is losing 2 electrons. All right. And Mn is +7. You should remember that KMnO4 has Mn at its +7 oxidation state. This is +2. So we can say that this guy is losing 5 electrons. To balance the equation, we'll have to multiply this by 5, meaning we should put a 5 over here and a 5 over here. All right. So 10 electrons are lost in total, and this should be multiplied by 2, meaning we should put a 2 over here and a 2 over here, so that a total of 10 electrons are produced. Now we can balance the other part of the equation as well, which is H2SO4 and all. Uh, you can see that SO4, there is just one SO4 over here, and there are 1 and 2 3 SO4 in total over here, right? So we'll put a 3 H2SO4 over here, right? And then what else can we see? What else is not balanced? Now everything has been almost balanced. 2 KMnO4, K2SO4, all right, that is also balanced. Potassiums are also balanced. So what could probably not be balanced is H2O. We don't even really do we need to balance H2O over here? Not necessarily. Why? Because they've asked how many moles of oxygen gas are produced when 1 mole of KMnO4 reacts. Over here, when 2 mole of KMnO4 reacted, it produced 5 mole of oxygen, right? So the ratio is KMnO4 is to O2, 2 is to 5, all right? So what would be 1? 1 is to 2.5. So if we use 1 mole of KMnO4, 2.5 mole of oxygen should be producing. I hope that makes sense. Next question. An alcohol ROH reacts reversibly with ethanoic acid to produce an ester. ROH plus CH3COOH, reversible reaction CH3COOR plus H2O. 3 mole of ROH, 2 mole of ethanoic acid, and 1 mole of water are mixed together. At equilibrium, 1.5 mole of CH3COOR is present. What is the equilibrium constant Kc of this reaction? So what would be the equilibrium constant Kc of this reaction? So to write the equilibrium constant, we know the formula for equilibrium constant is Kc is equals to concentration of products upon concentration of reactants. All right, concentration of products upon concentration of reactants. All right. Now initially it said there were 3 moles of alcohol, 2 moles of ethanoic acid, no moles of ester, and they also added 1 mole of water. All right. Now at the end 1.5 mole of this guy is produced, which means 1.5 mole of water must also have been produced. So 1 plus 1.5 should have given us 2.5. All right. And if 1.5 mole of COOR is produced, that means 1.5 mole of carboxylic acid and 1.5 mole of alcohol reacted with each other to produce 1.5 mole, right? So this should be 3 minus 1.5, which is equals to 1.5, and this should be equal to 2 minus 1.5, which is equal to 0.5. All right. So now we have all the equation. Moles of product, which is 1.5 multiplied by 2.5 divided by moles of reactant, concentration of reactant, which is 1.5 of ROH and 0.5 of the ethanoic acid. All right, and then we can get the final answer. We just put that all in the calculator. 1.5 times 2.5 divided by 1.5 and 0.5. All right, so we are getting the answer 5. So the answer is 5.00. All right. Next question, question number 14. Graph can be drawn to show the percentage of ammonia at equilibrium when nitrogen and hydrogen are mixed at different temperatures and pressures. Which diagram correctly represents these two graphs? All right. So this is kind of a tricky question. The reason why it is tricky is because it contains three things in a graph. All right, the graph contains three things. The graph contains temperatures, the graph contains pressure, and the graph contains percentage of NH3 at equilibrium. Beta, the graph basically, how would it work? You would have to know the equation of a reaction of hydrogen and nitrogen. All right, so we know that nitrogen and hydrogen, when they react, they produce ammonia, NH3. To balance the equation, we put a 2 over here and a 3 over here, right? All right. Now, few things about the Le Chatelier principle. You should also remember, you should also know, it is fixed. You should also know that the forward reaction of this equation is actually exothermic. The forward reaction of this equation is actually exothermic. All right. And the other thing you should know two things. The two things are, the first thing is that um, well, I'll write as statements. Okay, I'll write as statements because we don't have to write the whole Le Chatelier principles over here. We know that because forward reaction is exothermic. We know because forward reaction is exothermic. Just one second. Because forward reaction is exothermic, right? We know in equilibrium or in dynamic equilibrium or in reversible reactions, the increase in temperature is favored by the endothermic side. All right. So that means over here, because forward reaction is exothermic, we'll say lower temperature will produce higher yield. Lower temperature will produce higher yield. And the other thing about pressure, because other than temperatures, the other thing is mentioned is pressure. Okay. So what about pressure? We know that increase in pressure is favored by side with lesser moles of gas. You can see that there is lesser moles of gas on product side. On reactant side, there are 4 moles of gas. On product side, there are 2 moles of gas. So we'll say that increase in pressure will produce higher yield. All right. So that means the graph which is above, these two graphs with lower temperature, they must be correct. All right. And then the second thing that must be correct for them is that as temperature is increasing, yield should increase. So in option A, as pressure is increasing, yield is decreasing. So this is wrong. This is wrong. So the correct answer is D for doctor. All right. Because we can see that as pressure is increasing, the yield is increasing. And at 400 degrees Celsius, there is higher yield than 500 degrees Celsius. All right. I hope that makes sense. Let's move on to the next question then. Question number 15. The Boltzmann distribution for hydrogenation of an alkene at a particular temperature in the absence of catalyst is shown. Proportion of molecule with E. All right. Which row correctly describes the effect of adding nickel catalyst to the reaction vessel? Well, adding the catalyst does not change the shape. It does not change the shape, meaning the answer is either C or D, right? Only temperature changes the shape, and also pressure in some cases might be able to change the shape, but temperature 100% changes the shape, right? Over here we see that temperature is not of a factor. It's not asked about. Only catalyst is asked about. Catalyst does not change the shape of Boltzmann curve. What does it do? It just brings the activation energy back. It decreases the activation energy, meaning the answer is C. All right. So I'll write that down over here so you remember as well. Catalyst does not change the shape of Boltzmann curve. It only lowers the activation energy. It only lowers the activation energy. Full stop. Next question. Elements Y and Z are both in period 3 of the periodic table. When the chloride of element Y is added to water, it reacts and a solution of pH2 is produced. All right. So Y has an acidic chloride, meaning Y is neither NaCl and nor is it MgCl2. Okay. Next, when chloride of element Z is added to water, it dissolves and a solution of pH 7 is produced. So this means it could either be, this one could either be, this one could either be sodium chloride or it could be magnesium chloride. All right. And Y could not be sodium chloride and magnesium chloride, but it could be aluminum chloride, Al2Cl6. It could be silicon chloride, SiCl4. All right. It could be PCl5. It could be SCl2. Any of those. All right. So let's look at them. Which statement explains these observations? Both chlorides hydrolyze in water. That is not true. They do not. NaCl, MgCl2 does not hydrolyze. It dissolves. It does not hydrolyze in water. It dissolves in water. All right. Next thing, element Y is magnesium and element Z is sodium. Y cannot be magnesium. Y cannot be magnesium because it is giving acidic pH, right? Element Y is phosphorus and Z is aluminum. Z cannot be aluminum because aluminum gives acidic pH. Z is giving neutral pH. Element Y is silicon. That is true. Element Z is sodium. That is also correct. So D is the correct answer. Question number 17. Aluminum, silicon, and phosphorus are elements in period 3 of the periodic table. Each element forms an oxide. Which row is correct? Which row is correct? All right. Aluminum oxide, um, is it basic? That is not true. It is not basic. Aluminum oxide is what we call an amphoteric oxide. We've been studying that since O levels. All right. Aluminum oxide, does it have giant ionic lattice structure? It could have giant ionic lattice structure. So this is correct. So let's look at the next one. SiO2. Is SiO2 having a giant ionic? That is not true. So let's look at option C now. So A is wrong because of basic, right? B is wrong because of silicon dioxide. Now let's look at C. C, aluminum oxide has high melting point. That is a true statement as well. SiO2 has high melting point. That is also a true statement. P4O10, does it have a low melting point? That is also a true statement. So the correct answer is C. All right. Next question. Question number 18. Which statement is correct? The atomic radius of silicon is larger than that of aluminum. Is the atomic radius of silicon larger than aluminum? No, that is not true. Atomic radius decreases across a period. So aluminum has a larger atomic radius, silicon has a smaller one. The boiling point of chlorine is higher than that of silicon. That is also not true. Silicon has a very high boiling point. In every period, group 4 has the highest boiling point melting points, right? Silicon has the highest melting boiling points. The first ionization energy of sulfur is greater than that of phosphorus. Is the first ionization energy of sulfur greater than phosphorus? That is also not true. We say that ionization energy decreases across the period. Um, Ionization energy increases across the period. Um, Ionization energy increases across the period, right? But for phosphorus and sulfur, basically for group 5 and group 6, we know that it is an exceptional case, right? Group 5 and group 6 and group 2 and group 3 are exceptional cases in the notes. We see that group 2s and group 5s have abnormally higher ionization energies, right? So group 2 and group 5 have exceptionally higher ionization energy in each period. All right. So even though ionization energy across the period, it increases, right? It gets more difficult to lose electrons across the period, but sulfur has a lesser ionization energy than phosphorus. And the reason is, you guys must have answered it. It must have been asked probably in your P2 in this year's exam, or I have asked it several times. It is because the orbitals of phosphorus are half filled. All right. Therefore, it has a stable, semi-stable configuration. Sulfur has one orbital of a subshell which is completely filled, and two half-filled orbitals of that subshell. So that doesn't give stability much. All right. So that is also wrong. So the answer must be D then. The electrical conductivity of magnesium is greater than that of sodium. That is true because magnesium has a larger cloud of electrons. It has two delocalized electrons per atom of magnesium, right? Next question. All solubility data in this question is given at the same temperature. The table gives some data for compounds of calcium and compounds of X, an unidentified element in group 2. Calcium, its decomposition temperature of carbonate is 840, X is 1150. All right, solubility of sulfate per mole. So its solubility of calcium is this much, solubility of hydroxide is this much. All right, what is missing data for element X? Will the solubility be more or will it be less? That is basically the question. All right. So for that, you need to know a few things, and I can write that as a heading. For group 2 elements, solubility of their sulfates decreases down the group, and solubility of their hydroxides increases down the group. All right, so that means X, because it is obviously this guy is obviously beneath calcium. Why do we know it is obviously beneath calcium? Because its carbonate has a higher stability. Thermal stability of carbonates increases down the group as well. I'll write that down as well. Thermal stability of carbonates increases down the group. Thermal stability of carbonates increases down the group. All right. So this means that X is beneath it. So therefore, its solubility of sulfate should be smaller value than this. So what are smaller values than this? 7.11 to 10 to the power minus 5 and 7.11 to 10 to the power minus 5. So the answer is either A or B. All right. And now solubility of hydroxide. Well, solubility of hydroxide should be more than this. So in option A, 2.0 to 10 to the power minus 5, solubility has decreased. This can't be correct. This can't be correct. So the correct answer is B. All right. Both these values are correct. 3.37 to 10 to the power minus 3. That is an increased solubility when we compare to 1.53 to 10 to the power minus 3. All right. Next question. What is the total volume of gas produced measured at room conditions when 0.1 mole of anhydrous magnesium nitrate is completely thermally decomposed by heating? So for that, we need to write down the equation. All right. Uh, we know to calculate the volume of gas, we write the equation volume is equals to mole multiplied by 24,000, because the answers, as you can see, are in centimeter cube, right? All right, 24,000. So now we have to write the equation so that we can solve this question. All right. Magnesium nitrate Mg NO3 hold twice. When it undergoes thermal decomposition, beta, what does it produce? It produces magnesium oxide, nitrogen dioxide, and it produces oxygen, right? And then we put a 2 over here to balance, and we put a 1 upon 2 over here to completely balance, right? So we can say that 1 mole of magnesium produces 2.5 moles of our gas, right? 1 mole of magnesium produces 2.5 moles of gases, right? Why did I sum these two up together? Because they are asking total volume of gas produced. Okay. Now in the question, it is asking 0.01 mole of magnesium. How much would it produce? X, right? So X would be equal to 2.5 times 0.01. All right. So what is 2.5 times 0.01? It is 0.025. All right. So 0.025 moles of gas would be produced. Moles of gas would be produced. All right. So the formula becomes 0.025 multiplied by 24,000. So we'll just multiply it by 24,000 and we are getting the answer 600 centimeter cube. All right. So this is our answer 600 centimeter cube. I hope that makes sense. Okay. Any questions? This will be the total questions we do today. Inshallah, in the next class, which is tomorrow, we'll do the other half of this paper.